have started the recording as well. So, first of all, welcome Sayantani for this session and thank you for accepting this. We'll start with the introduction. First of all, with the background of the topic that we are going to see. So, we'll see how CRM Analytics will leverage time series to predict the trends effectively. And we'll be covering the approaches for trend forecasting, and we'll be diving into a few of the real world use cases as well as demonstrating the value of time series in identifying the patterns and make informed decisions, and as well as driving the strategic growth with this. And moving to next, just a quick introduction for the group of CRM Analytics tab user group. So we are community which mainly focus on the data analytics part, and like how to unlock the insights out of data and how to make the impactful decisions out of it. And we primarily focus on Salesforce CRM Analytics data as well as Tableau sessions as well, couple of them. So if anyone wants to give a presentation, or if anyone wants to share their knowledge over here, so feel free to reach out to us in via LinkedIn. So a quick introduction about myself. So my name is Navin Aswani and I'm a co-leader for CRM Analytics user group. As well as I'm based out of Dubai, I have my own company. I'm co-founder of Cloudly and working as a data architect over here. I have a co-leader, which is like he has not joined today, but he is based out of US. So we run this group together, and if you have anything to share with us to the community, you feel free to reach out to us via LinkedIn. So over to Sayantani, if you can just give a brief introduction about yourself, and then you can take away the screen as well. You're not audible, sorry.
Okay, so some of you already know me because I have seen these names or I have spoken to you guys multiple times. For those of you who don't know me, I work at Conservice, which is a commercial real estate data company in based out of Utah primarily, but we are the environment, sustainability, and governance group. So we are mostly located in Chicago, and we use Salesforce as our base, but we also have other tools like Postgres database from AWS. We also use Azure. We also use a lot of other clouds. The beauty of being in this company is it's takes part of Salesforce, but the rest of it is completely custom built. So we don't use sales and marketing here. We don't use Salesforce for sales and marketing. We don't use it for, technically, we don't even use it for services like taking service calls or anything. So this kind of environment gives you a lot more in-depth ideas into what Salesforce does and the power of Salesforce, because everything you build in it is from scratch. That's how CRM Analytics is, at least to me. We have to build everything from scratch. You cannot use any of the templates that Salesforce has. None of the templates. You can still do maybe the dashboard templates, but not the app templates because they don't work for the kind of work we do. Also, Navin, is it possible that people can ask questions while we are talking, or is it not possible?
Yes, definitely. So there is a chat window. So if anyone has a question, please feel free to add the questions over there. And in the end of the session, we'll take that Q&A, or maybe in the middle, I'll interrupt Sayantani and we can ask the question.
Great. So, sorry, I like keeping the sessions interactive so that I'm not the only one who is speaking continuously. Please feel free to chat, raise your hand, and Naveen is going to take it from there. Thank you, Naveen, for inviting me. I'm going to stop sharing my video so that my screen does not go bonkers. Share screen. Please let me know if you can see my screen, but I'm going to try sharing this way. Let's see. Nope, sorry. Uh, my laptop doesn't have a function anymore, so I need to redo this. Let's see. Can you still see my screen?
No, Sayantani. I mean,
All right. Okay. Let me get out of that mode. Can you see my screen now? If not, then I'm going to just do full screen.
yeah,
Yes, that
not.
not right. Oh, can't access system. Restart your browser. Okay. I cannot share my screen. Uh, Navin, can I send this to you so you can share?
Yeah, sure.
Okay, let's do that. Um, where should I send it? WhatsApp? If that
I'll uh,
works.
I'll
You
send you I'll send you the email ID. You can send it to me there on WhatsApp.
okay? Sorry, guys. Technical challenges for technical people. Copy. Okay. Okay, I just sent it to you. I'm still going to try while Navin is doing that to see if I can get it to work. Can you see my screen now? Because it stopped complaining.
No, I cannot see. And
Just a
someone from the participant, if you can see the screen, you can just text.
uh, this is simply to restart the browser. Okay, let me restart and see if that works. 1 second. System settings. System settings. Screen and system sharing. Uh, Navin, can you please share? And I'm going to start my video. And while Navin shares, I am going to start anyways. Okay, so time series. Time series, most of you might be aware by now that it works with, there are three, it's basically a way to do forecasting of data into the future. One big reason we like doing forecasting is you don't always have the most recent data. We are not doing we don't always have most recent data, especially in the type of fields you work. Let's say you are doing bill payment. You don't always know what kind of bills are going to come your way to do bill pay, or what would be the amount of bills that are coming your way to have a budget made, right? So if you want to have budgets made well into the future, maybe 3 or 4 months, based on the previous data, you need to have some kind of methodology to figure out how much you should budget for. One way of doing that is simply taking an average or taking maybe last 2 years data and then saying, okay, based on this, let's take, let's provide this amount into the budget. But that's not always going to be accurate. I'm not saying the ways that we do in CRM analytics are very accurate, but at least it's not an average or not someone's guesswork of what it should be based on some random data they found somewhere, right? Navin, can you share the screen or
I was about to interrupt you because I haven't received the file yet.
that's interesting. I did send it.
I
Uh,
mean, just validate the
okay,
in now. Now I received it. Yes.
sorry.
Now I received it.
Okay, great. Also, if someone wants that presentation, though it's a very short one, we can send it to you, I guess. Thank you, Navin. So, can you go to the next page, please? Next slide. Okay. So, what is time series in general? So, it's a statistical method. It takes your data points that are collected sequentially over time. So, if it is random, it does not work. There has to be a sequence. You might miss a month or you might miss a day in between. That's totally fine. But if you're missing a large chunk of data that you're trying to do an analysis for, that's not going to work. It Based on that, it allows analysts to identify patterns, trends, seasonal variations within the data. So instead of saying randomly that, okay, because it was in the last May, we had $1,500 for, let's say, for paying our bills, let's put 1,500 this year as well. It might not have been 1,500, but the data, if you run some other statistical models, it could have been 2,000, it could have been 500. But just because last year it was 1,500, you're putting 1,500 this year, that doesn't make any sense. That's why the patterns need to be identified, and accordingly trends are set, and it also takes into consideration the seasonal variations. Seasonal variations is does not always mean winter, summer, and fall, all those things. It can also mean there is a season of shopping. Like if you are in US, it's Thanksgiving and Black Friday where your shopping goes crazy. Then if you're in India, where I am from, it's all our festivals. So Diwali, then you have the Holi, you have thousands of festivals. All of those are when the sales of the shops spike. So seasonal variations can mean different things to different people. And this is not, we are not talking about summer, winter, fall, and spring. It can totally be, but we're not saying that. To make predictions about future values based on historical trends is what we like to do. There's one more thing that if you look for time series, it doesn't tell you, but internally, I love using this to find data anomalies. Because if you have very good data and then suddenly you have a spike or a downfall in the, let's say, in your, because we're talking about sales, in sales, suddenly you might actually not know that did someone not put in the correct value or they just multiplied it with 1,000, right? So time series helps you figure out if your data is within a range of what it should be based on the previous history. Yes, there is something called garbage in, garbage out, which we all speak when we are in the world of data. So if you're saying garbage in, garbage out, however good your data is, that is how good your predictions will be. And to the extent that internal in our company we have seen it hit the correct decimals as well. It has been so good in some cases. And of course, then there are things where if you try doing based on real sporadic data or data that is not very good, those values can go real crazy real fast. Then the next one is, it's basically a way to study how data changes over time by analyzing your data points recorded at consistent intervals. So you can do 2 months, you can do 1 month, you can do a year, you can do every day, you can do every hour, doesn't matter. As long as there is consistent intervals and you have data in them, it's going to take, you will get a good time series analysis. Naveen, next slide. And please ask questions, interrupt, whatever you want to call it. Okay, so the key points. As I said, data cannot be random. It has to be at regular intervals. You identify the patterns, you do the trends, you do the seasonality, you find the seasonality in the data. For us, or at least when you are using time series in CRM Analytics, we don't have to figure out what the seasonality is. In a few cases, the system finds it, the code finds it itself and tells you what it will be based on the data you give it. So, which is something I like. We are, as humans, we wouldn't be going through millions of rows and figuring what it is. Let's use the tools to tell us what the seasonality will be. Forecasting, of course, you can do forecast future values based on the pattern, but I would still warn, please do not go crazy into the future, maybe a couple of months, maybe a couple of years if your data is yearly, or maybe a few days or a week if your data is daily. But please do not do, let's say, next 12 years what is going to happen, because then your final values will start looking real crazy. Next slide, Naveen. Thank you. Okay, some examples. I already gave the sales figures. You have website traffic, which also, if you look at things like Amazon and Macy's, that it can go crazy to the extent that a few years ago, before COVID, maybe 2017 or 2018, actually Macy's, which is a major retail store in US, actually crashed because during Black Friday, because of the amount of people who were trying to get things from Macy's, their website actually crashed. You have stock prices, of course, over time, but uh, one thing about stock prices is it changes so much every second that I don't, people use it, but time series to predict it, but I am not very fond of it because there are way too many other factors playing into stock prices. Weather data, yes, but again, a fair warning that weather data is not something we should be predicting or we can predict, because anything can happen at any point of time. Especially living in Chicago, we get from sunny to cloudy to rainy to snowy to whatever you want to call it, everything happening in a single day. So there is no way of predicting that if you're in these kind of situations. Sensor data is a very good example. We do it for sensor readings, we also do it for utility billing, but because it follows a pattern, it follows a it follows intervals, we do it for these kind of sensor readings, utility data readings. Sales figures is a very good one. Those kind of things are where you should be using uh, time series. But yes, after using, please have your eyes look at it, because ultimately you know your data the best and not the platform itself, or not the analysis that it is doing on. Next slide, Naveen. Okay, now comes to the three ways we do the time series in CRM Analytics. So we do hold filters in dashboards. We also do hold filters in recipes. And then we have Arimax in dashboards. So Now, next slide. These are the only three ways. Otherwise, you can, the other couple of ways that does exist, but I don't call them time series, is you can do windowing functions and find out your average over the last 3 months, 6 months, 12 months, all of those kind of things. Or you can simply do just the average of the whole thing. But those methods do exist, but I have compared all the different methods and found that as of now, Holt Winters is the best method you can use to do this. Okay, so Holt Winters, what is it? This one uses time series behavior. So it uses a value, which is average, let's say. It uses a slope or a trend over time. It also uses cyclical repeating patterns, which again means seasonality. And as I said, seasonality doesn't mean our seasons, but some kind of seasonality, some kind of pattern it's noticing in the data. One another good example of this is the so Navin, does Dubai have bikes like cycles, those bike stands and things?
Yeah, they do have. Yeah.
They do have, right? So Dubai has, Chicago has, New York has, a lot of cities now have those bike stands. New York calls it city bikes, Chicago calls it divvy. Every place has their own names. So if you're taking those, uh, you can actually predict when how often will your bikes be used and which locations need the most bikes. If someone wants to play with data, I would say use the city bike, or if Dubai has public data for Chicago, sorry, for bikes, Chicago has public data for Divi. Use that and try doing analysis on top of that. The other thing you can do, which most of my blogs are based on, is using taxi data, which is also there for most US cities as public data. Should be there for some other cities as well, like Singapore and all. They should also have public data for taxis. That is also a very good analysis you can use time series to figure out. Okay, next slide, please. Uh, Arimax. So for Arimax, we use autoregressive. It's basically an autoregressive integrated moving average of exogenous inputs. I know it's a mouthful. That's why we shorten it and we call it Arimax. Basically, it's again a moving average, very similar to 3 months, 12 months, 6 months, whatever you want to use. And then you are adding an exogenous input on top of it. What does exogenous input mean? It mean it means you're putting an external factor on top of it. So in statistics, there's something called ARIMA, which is autoregressive integrated moving average. So you're taking a moving average. On top of that, you're adding an external factor, which in this case can be seasonality. And then you are making a prediction which will be more accurate than just using a moving average. Make sense? Okay, next slide. Guessing that is the last one. Okay, so I will take questions first before I try diving into the time series in CRM Analytics, if there are any questions. And Naveen,
No
I'll,
questions.
no questions, right? Okay. Naveen, I'll try resharing because now I'm going to use Chrome. Let's see if that works. Otherwise, I'm just going to post the links in chat.
Sure.
Let's see. So, takes me there. Okay, this works. Great.
Yeah.
Okay, finally. Okay, so I'm going to start with Arimax because I don't want to spend the next 30 minutes on it, maybe the next 10, 15 minutes. 10 minutes, and then I'm going to move on to. So the way I'm doing it is I'm showing you at the dashboard level and at the time series in sorry hold filters in the recipe. So two different things, but I'm not showing you my data because I cannot. Um, so I'm using what Salesforce gives because it does a very good job of telling you what you need to do and how you need to do. So also, one big caveat, you do not need to be a data scientist to do this. I just have an educational background that helped me a little, but you don't need to be an expert data scientist to do any of this. It's basically understanding some math, be a data person, understand math, understand what you're trying to get at, understand your domain, which is extremely important, and you will be able to do this. Okay, so Arimax, it uses existing data points to predict your future data points. And how do you use it? It's a variant of time series statement that provides a different algorithm to predict data points. So a good comparison when you're trying to do analysis for your company or for your own benefit, do it all the three ways. One, use Arimax in dashboards, use Holt Winters in dashboards, and use the data that's coming from recipes. And for the same data set, merge all the three together. I know it can be a crazy cycle that you will ultimately be looking at, but trust me, if you do that, you can guide your users and clients to show them which one is a better analysis. And you don't have to spend a long amount of time coding it in R or Python or anything, because this is taking everything into consideration using just a few statements, right? So much better better to use this than go any other route. Okay, so it's as simple as saying Arimax, which for Holt filters we say time series, then whatever is you're trying to do, the the query. So result set, you generate whatever is your measure as this is your second measure with the parameters. Now, what are the parameters? How do you order it? If there is a seasonal order, it may or may not be used. But if it is, then these are the integers, you put in the values, you order it in the degree you want, which is very confusing. I know it takes a very long time. And this, honestly, the problem with doing this part is you have to do a lot of uh, you have to do a lot of permutations and combinations to figure out what is the right sequence. Okay. Of course, then you can do external regressors or cofactors. So you can take multiple regressors. So if it is sales, if you're budgeting for sales, you can take number of products and or the number of people who ordered for it and all those the number of accounts that have been related to as the different columns, and then you can use those as your external factors to get your Arimax methods. But there's a limit of 10, which I think is massive, but maybe not for your case. Then what is the length you're looking for? As I said, please do not go crazy on the length, because you will see some really, really crazy data if you do that. It says example length is 6. I have done 3. I have done 12. I stick to saying 3 or 4 is the best. And after that, it kind of goes crazy from there on. But that's based on my analysis of the type of data I have handled. It can be very different for you. It can be very different and it can vary from project to project. If the data is very consistent, let's say over the last 36 months, it would look really good. But after that, for a very long time. But if you have seasonality, you have major issues coming in the data, then it will not be a very good analysis after 3 or 4 of the future data points. Of course, you can do all the different types of date fields. So year, month, year, quarter, year, month, day, which is basically the whole date, year, week. Mm, choose what your data is based on, and accordingly you can do. There's one more thing that I would like to point out here. Though this says year, month, day, you can actually roll it up in recipes to aggregate it to the year or to the month and then do an analysis. Just because your data comes as year, month, day does not mean you have to do year, month, day only, and you cannot do the analysis based on year or month or quarter. So again, depending on your use case, what you think is best, please do that accordingly. Ignore last is something I always love putting it. It says that by default it is false, but I like calling it ignore last as true. One reason being you might not always have whatever is your last data point to be complete, because data comes in, technically data comes in after uh, in arrears, right? If it is not stocks, your data is always coming in arrears, so it can be, there can be a lag of say 15 days, maybe a day, maybe 3 or 4 days, whatever. Because there is an arrear, I always like to put ignore the last one, because I don't want to take the risk of saying that yes, I have complete data at all points of time, which is true in very, very few cases. Then of course you can order it. How do you want to order it, based on what? And then you can also say I ordered by week, or I order it by year. I usually say order it by year and month. And then prediction intervals, this is there even in times in whole filters. You can do your prediction intervals based on 80 or 95. Doesn't give anything else, it's always 80 or 95. That's the confidence intervals. So there's nothing more than that. And then this goes into a lot of examples. I was giving this example a few minutes back of uh, energy with precipitation and temperature, which is also a very good use case to take into account when you're doing seasonality. Uh, and then we will look into, are there any questions, Naveen?
No questions as of now.
Okay, guess people have no questions today, but sure. Okay, I'm going
I'll
to read.
quickly ask
Uh,
one thing. So I'm active user of Alteryx, if you might have heard. So that's a data blending tool that I use on a daily basis. So in that, I also use time series, but there are
hmm.
different perspective of people. Like I wanted to hear from you, like what is the data volume here we are talking about? So if you want an accurate trend, I would say, I mean, even if it is 90-95% accurate. So also let's consider we are taking last 6 months of data, last 12 months of data. So what is a good data volume it should be there to get that predictions out of it?
Excellent question. So first and foremost, time series, at least CRM Analytics says you should have a minimum of 2 data points.
Okay.
As a data scientist, I say you should have a minimum of 20 data points. Any kind of statistical analysis you want to do, the more data you have, the better the prediction will be. Having said that, you should not be predicting anything where you have less than 20 data points.
Okay.
Make sense?
Agreed. Yeah.
So, yes. Okay, going back to sharing my screen. This is the last part of it. And please tell me if you can see my screen.
Yeah, it's visible.
Okay. Whatever happened the first time, I don't know, but now it's working apparently. Time series forecasting, transformation, forecast measures. Now, one big difference between doing it in dashboards and doing it in recipes. In recipes, you do have some control, like here. Let's increase the screen size so you can see this. Let's see. seasonality. You do have this in recipes, where you can select the seasonality, your model as in additive or multiplicative, and do you want to generate intervals or not. The difference between doing it here and doing it in dashboards, you can use bindings and give your users the capability to say, okay, I do want to use additive and I don't want you to figure out what my analysis should be on, or I want seasonality or I don't want seasonality. You can give that access using bindings to your users. But if you're using it in recipes, you don't your clients or your users don't have that anymore, that ability anymore. It is up to the system to figure it out. And having said that, there's one more caveat, which is, if you do seasonality auto, model auto, those two, your recipe is going to take a longer time to run. I run millions of rows through the system, and millions in the sense hundreds of millions of rows through the system, and it takes about 5 hours to finish this. But if you choose that I don't want any seasonality and my model should be additive, it doesn't have to select based on the grouping that you have provided it. It runs much faster. It can run in less than an hour. But if you do multiplicative, it increases a little because it becomes a little more complicated with seasonality. So ideally, if you do seasonality, do multiplicative. If you do no seasonality, do additive. But that's just my suggestion based on the data that I have worked on and people I have spoken to. Your data can be different, so try different versions, see where you get the best answers from, and then continue doing that. Also, uh, if you have worked on Einstein discovery, one thing that you would have noticed is you should run your models on a regular cadence because of the data that is coming in. If you change these to, let's say, being additive and additive with no seasonality, or with seasonality and multiplicative, please go back once in a while, rerun it on a different rerun it to see if those conditions are still giving you the best answers or the best predictions. Because as data comes in, this can change as time changes, or as your as time changes, or things that are impacting the business, these can change. So just a suggestion to keep setting it keep looking at what you have done, so that you're still giving your users get the best value from the system that you are working on. Okay, let's that doesn't work. Okay. So for time series, it's again, you select a column very similar to what Arimax was doing, or how you're going to do hold filters in dashboards. You select what you want your column to be, and you can forecast multiple columns, by the way, if you're using it in recipe using the same query. I have done up to 10. You may go further. I have done up to 10 and it works really well. Of course, it takes time, but it works well. What you want it to be grouped on, you can again add multiples of these. Time series, what is the date for it, which date you are basing it on, then what is the forecast. In this says time period to ignore none. Usually, this is what I was talking about in Arimax. Ignore last is what it is in dashboards. Ideally, make it true instead of saying none. And forecast outlook is rolling. This automatically comes, and how long you want the forecast to be. In uh, the recipes, if you say your forecast length is 12, it takes the whole data set and finds whatever is your last date is, not by the group, but whatever. So say you wanted your data set to be predicted only for the next 3 months, but say one of your periods is in 2026 December. It's going to predict 3 months from 2026 December. So, what I would suggest is trim it down to the last period you actually want it to predict from. You don't need to predict, you don't need your whole data set to go to 2026. So, trim it down. Let's say I want and filter it to the, let's say, only till last month, and then you don't have to go in every month and change it, right? So last month or last 2 months, and filter it there and then let it roll. That would give you a much better prediction than doing an analysis for something you needed 3 months from today and not 3 months from December of 2026. Okay, columns forecasting, of course, I just said you can do all of these different things. Usually sum, average, maximum, and minimum are the ones you would use. You can group by the rows. It's you can or cannot. It's totally dependent on you, depending on how complicated you want the system to be. Of course, then you have your forecasting period. You can, as you can see, you can go up to 100, but you can do 3. This is what I usually set it to. So this is what was the ignore last, which was in Arimax. It's the same thing in Holfinter's time series in dashboards. So none include all data or last time period up to data up to, but not including the last time period. So if you say ignore is true, this is what kicks in, this part. Rolling is basically, you're saying when you're looking at forecasts here, you're saying rolling, which means you're taking either 3 months or you're taking 4 months or you're taking 5 months, whatever you want. So if you take, so if your data isn't up to date for 2 months and you're forecasting out 3 months, then 5 months data is predicted. That's what I was trying to get at. Then, of course, I already explained you the seasonality part of it and how seasonality works. So you have auto, none, you can select quarters, you can select the date quarter, whatever you want to do. Multiplicative, additive, and auto. So as you can see, if you do, this is why I was explaining this before. If you do additive, it means the seasonal variation are roughly constant. So that's why you can technically turn off seasonality. If you do multiplicative, there is season, and that's why multiplicative kicks in. So that's the difference between additive and multiplicative. And then confidence intervals, of course, exactly like Arimax, you do 80 and 95% confidence intervals and look at it. It's basically in the transform node. If you want to look at it, so this is going to open up only and only if you click on the transform button. Otherwise, it does on the number columns, on the numeric columns, it does not show up if you do on date columns or the dimension columns. So you have to select a numeric column to open up time series. That's about it, and I'm going to stop sharing. Okay, we have no questions. Okay, Navin?
Yes. So, you done your part. Is there anything that you want to share?
Not me.
Okay,
Uh, if there are questions, if someone just wants to hang on for the next 10 minutes, I'm there.
sure.
You need not ask questions only on time series, guys. You can ask on anything.
I guess then we are good. I mean, we can.
Yeah, yeah, exactly.
Okay, there is one question from Geeta, and she's asking that I'm not a data scientist but would like to know more about these statistical analysis. Where can I best learn them?
Uh, of course. So multiple ways. One, my suggestion would be, if you're looking at CRM Analytics or Tableau, I would say use those resources or use the blogs. I have blogs on them. Ricky has blogs on them, which is called Salesforce. Hers is Salesforce salesforceblogger.com. If you want to learn in general, there's something called Analytics Vidya. Let me search Analytics Vidya. Yeah, Analytics Vidya. It's awesome. I know I'm talking about an Indian platform, but it's awesome. You can sign up on their website. They send you regular emails. They have articles and blogs on them. You also have some Python bloggers who talk in detail about different types of statistical analysis and how they should be done. So, great question.
Adding one more link, I mean, this is also shared by one of my clients, so they strongly refer to this particular link to understand more on time series forecasting.
Just on time series, yes. Should we focus more on Tableau Einstein now or okay? This keeps coming up, and a great question. So, Tableau Einstein is a new platform being developed that uh, is baked into Salesforce, but technically, from I think February of, and don't quote me on this yet, but technically, we have been told from February you can use any kind of data. It does not need to live in Salesforce anymore. But Tableau Einstein is totally new. They are getting the best of Tableau and the best of CRM Analytics together to do this. CRM Analytics is not going anywhere because there are tons of clients who live in the world of CRM Analytics, and that's being heavily developed. Tableau is also being heavily developed because there are more clients on Tableau. So maybe someday they're going to say, okay, we are merging everything. Like when we moved from data flows to recipes, that was a converter. Maybe someday they're going to do it. Not in the next 3 years. CRM Analytics is being heavily developed with things that we have been asking for long. All of those are coming in. So keep working on CRM Analytics as of now. It's not going away anywhere. Neither is Tableau. For those of you who are working on Tableau, it's not going anywhere. Tableau Einstein is just a shiny layer getting the best of both worlds together. That's it. And I know a lot of people have said, no, CRM Analytics is going away. I have spoken to the PMs. No, it isn't. We also recently, as ambassadors, we got a roadmap as well, which gives us next three releases, what is going to happen. And so, yeah, yes. I'm a CRM Analytics. This is a question from Geeta, but I find that not many customers are willing to spend more time on the instant discovery. No. To do instant discovery, you have to have good data. You have to have an understanding of things. People don't like using it. One big reason being no one wants to spend time and do statistical analysis, but just see things on dashboards and be done with it. That's the reason people don't spend more time. And people who do, like our company, we do a lot of Einstein discovery, and I would like to do more if I get the time. But one big reason is just people not understanding the value behind Einstein discovery. They would rather ask ChatGPT, show me my anomalies, than go into Einstein discovery and look at it. It's very effective. Also, I have heard cases where uh, people have said, oh, I can do this, but I am not willing to, I can do this in Python. Why should I be doing it here? If you're doing it in Python, you're going to take a week to develop the seven, I think, different models right now that exist in Einstein Discovery, or more. You'll take more than that. But if you do an Einstein Discovery, it takes 15 to 20 minutes, depending on how much data you send it, to tell you which is the best model to use. And honestly, I have done that. I was asked to create something in Python, and I said, okay, I have a different tool. I'll send the same data through I sent the same data through Einstein Discovery, told me which is the best model to use. I went and showed it to the clients that this is the best model to use. What do you want to do? And they said, okay, if that's the best model, we'll use it. And then I developed it in Python. So it's a great tool to use. It doesn't take you 7 days to build one model, which is what I love about it. Correct. Garbage in, garbage out. So anytime Shubhadeep, people say that our data, why is our models not working? Tell them garbage in, garbage out. And no one wants to clean it. Yes. So when I take interviews for uh, uh, people coming into the field of data in our company once in a while. And one of my first questions is, do you like working with messy data? If someone says yes to it, I do ask for a few examples. But if you have not worked with messy data and you have always been given refined data or already curated data, you have no idea what you're getting in when you come to the real world. And yes, no one likes to clean it. It happens in our company as well. No one wants to clean the data. It's a genuine problem, a problem that in the world of science, there is this thing that goes on, that most people who come into the world of data science, they just want to build new models. None of them actually want to look at the data and see if their models will actually perform well. They will just create the model. They won't even look at the data. They say, that's not our problem. If the data is wrong, it is your problem. You are doing the model. It is your problem if you don't have clean data.
Good answer to that question. Yeah, agreed.
Anything else?
I guess that's it. We can wind up the session, but you know where to reach out, Sayantani. You know where to reach out me as well, so you can just directly ping on LinkedIn if you have any questions. And thank you so much, Sayantani, for taking out time for this.
Thanks for
Mm,
inviting.
thank you. And as a token of appreciation, I would reach out to you. We'll be having Tableau swags for you. So,
Wow, thanks.
whomsoever is the speaker over here, they'll be getting that swag. So, I'm also motivating the participants as well. If you have anything to share, do definitely reach out to me. We'll arrange a session and you would be also eligible to get Tableau swags. So, thank you so much. Thank you all for joining. Thank you, Santani, again.
Thanks, Navin.
Thank you. I'll close this call. Thank you. Bye.